All right, welcome everybody to another installment of Sky Tonight, the Fleet Science Center's Planetarium Talk. My name is Andrea Decker, and I'm very excited that you are joining us again tonight for another virtual show. Before we get started, a couple of things I'd like to share. Super exciting news! The fleet is opening this Friday. Woo! In limited capacity for the beginning, so we will be open on weekends from Friday through Mondays. So we'll be closed Tuesday, Wednesdays, and Thursdays. We don't know for how long that'll be, so we will let you know when Sky Tonight will be back in person. We haven't found a date yet. It all depends on, where things go, how things work. There was exciting news all over for California, so we'll see if it all works out as planned. But know that we're getting ready to reopen, and we are excited to hopefully see some people in the building this weekend and welcome you all back for some hands-on fun. We'll do it very safely, of course. There's, masks or face coverings will be required. We will have extensive cleaning throughout the day in all of our exhibitions, and all of our staff and volunteers will go through a health check every time they enter the building. So it will be, we'll make it as safe as we can so that you can come back and enjoy and feel good about coming back. All right, a couple of other things for tonight. If this is your first Sky Tonight, welcome. We're excited that you found us and hope that you will stay with us. Normally we host these on the first Wednesday of every month in our Haikov Dome Theater, which is a beautiful dome theater, so it's all around you, and we throw stars up on that screen, and since it's half a sphere, it's just 360 sort of cinema, so it's really fun. If you haven't seen that, we're excited for you to experience it when we can go back in person. If you've been here before, welcome back. Thank you. The way it works is that we start, Dr. will start her presentation with some astronomy news, and then she goes over to the sky tonight. So she's going to explain the sky as we would see it when we walk out tonight at 8 p.m. And then she's going to go to the topic of this month, which is space junk. And then once her presentation is over, we'll take Q&A. If you have questions, if they pop into your mind, just write them in the Q&A function right away. You don't have to wait until the Q&A section. You can just go ahead and click that speech bubble sign that says Q&A, type it in there, send it to us. And if we can, we'll take the questions in between. It just very much depends on the flow of things, but we will try to get to your questions at least at the end. And during the Q&A, I will also pull up a short survey, a short audience poll. If you will take a second to fill it out while you listen to the Q&A, that would be awesome. All right, without further ado then, I'll kick it over to Dr. Lisa Will, our resident astronomer and physics professor at San Diego City College.
Well, thank you so much. It's great to be back with all of you. As much as we are hoping to get back with you soon in the planetarium, we are grateful that we have been able to bring this programming to you every month. And this month's topic is space junk, so hopefully we're going to have some fun with that. But before that, we're going to get to some stuff in the news. There's a meteor shower this month, the Lyrid Meteor Shower, which will peak before dawn on April 22nd. This is a case where it peaks every year at about this time, and it lasts from about April 16th till April 25th. And so when you're going outside later this month, if you notice more meteors, more streaks of light going across the sky than usual, you're likely seeing one of the Lyrid meteors. Its name comes from the fact that the radiant point, or the point where it looks like the meteors will be emanating from the sky, is located in the constellation Lyra, next to the bright star Vega in the sky. And meteor showers occur when the Earth's path crosses the orbit of a comet. And so this is little bits of ice and dust burning up high in our atmosphere that you can see as streaks of light. And so the best time to check it out this year is before dawn on April 22nd. Oh, so this might look like an image you remember from a while back. The Event Horizon Telescope collaboration posted the first ever close up image of a black hole. Now, this might look at first glance to you like the same image, but you'll notice the little swirly, the things that you're seeing in it, that swirly pattern there. Well, this is a signature of polarization. You may know polarization, like maybe you have polarized sunglasses, and you've noticed that you can't see the face of your cell phone very well unless you have to turn it, because polarization comes from when there's particles that align that allow light to be scattered at particular angles. Now, in this case, this is occurring where particles are aligned along the magnetic field of the black hole itself. And so we're seeing the polarization here is showing us information about the magnetic field of the black hole located in the center of M87, which is an extremely large galaxy located in the Virgo constellation. So this is the first time we have been able to actually truly glimpse detailed information about the magnetic field of around a black hole. All right. There was a news story today that some of you may have heard, and I wanted to bring it up, even though it's a really sort of esoteric one that's kind of hard to explain. But some of you may have been seeing news headlines today about like new physics. It's like, okay, so what's going on with the new physics? So, physicists at Fermilab who are studying properties of a fundamental particle called muons noticed that. All right, here's the deal. So, elementary particles can spin in the presence of magnetic fields. And so, what you're seeing right here is actually a very large device that generates magnetic fields. If you look closely, you can even see there's like a person in here. So, this is a huge, huge room with this device in it. And so, um, the elementary particles spin with a predictable pattern, and it conforms to what we call the standard model of physics. But muons have always been just a little bit off from the factor of that what we think they should spin with. And so the idea is that perhaps there is another particle that they're interacting with that is giving them a kick, that's making them spin a little bit faster. And some of those particles could be ones we know about, like photons or hadrons. But the behavior is such that it's like, well, maybe there is actually another fundamental particle that we have yet to discover that's giving it this kick. So there's also, though, as this announcement was being made today, there's actually a paper published in Nature that's saying, oh no, it's all good. This is exactly what we expect from the standard model. So let's just say the moral of the story is that there's still a lot to be learned in particle physics, and we're still trying to figure it out. But I figured some of you might have been seeing some headlines about particle physics today, so I thought I would at least bring it up to you a little bit, even though it's a weird one to try to explain. Sometimes I feel like the particle physicists really just make up a new particle every time they can't figure something out. But it is a really interesting problem trying to actually uh, figure out something that they've known as a discrepancy for the last 50 years. This is a long-term problem they've been trying to figure out. And that's some of the astronomy related current events. And you might be wondering, how does this relate to astronomy? Well, if there are fundamental particles of nature that we haven't discovered yet, those might be part of what adds to the dark matter problem in astronomy. So that's how it actually does relate to being not just a physics, but an astrophysical problem as well. All right, now let's take a tour of the sky tonight. And as our lovely host Andrea said, we set this up so it's like what the sky would look like when you could go outside after we're done tonight. So I have this set for about 8:30. And to let you know your orientation, north would be to the top of the screen and south to the bottom, east is to the left, and west is to the right. So straight up is pretty much right in the middle of your screen. And I always like to start this off by throwing up the mythology of the sky on the screen, because when a lot of people think of constellations, they think of the stories. And so these are the mythological representations of the constellations that are above us here in San Diego at 8:30 tonight. And they have names. Some of these names for these constellations date back a couple thousand years. Some of them are much more recent, say dating back to the 17th century, because that's what astronomers consider recent, right? But one of the reasons I like to bring that up is that means that constellations are patterns of stars. And because we, over the course of human history, have been talking about them for literally thousands of years, it gives you an idea of how long lived stars are and how far away the stars are, that they haven't moved appreciably and changed over the course of human history. But when you go outside tonight, you're not going to see these illustrations up in the sky, but the human brain does attempt to connect the dots in between the stars. So you're likely to go outside and your brain will automatically try to do stick figures. And so when I do the tour of the sky, I like to use the stick figures because that's what your brain tries to do when you look up in the sky. So let's start off with a rather famous constellation up in the northern part of the sky, which is Ursa Major, or the Big Bear. And this is the third largest of the 88 modern constellations that astronomers use. It's so like takes up a huge part of the sky, but a lot of it isn't bright enough for you to easily see from a large metropolitan area like San Diego. So when you go to look for the Big Bear in the sky, what you've usually been looking for is the Big Dipper. And so this is what we call an asterism. It is made up of stars that is not a designated constellation. This is the what you want to look for up in the sky tonight if you want to take a look for Ursa Major, the Big Bear up in the sky. A constellation you may have seen over the course of the winter because of the bright star Capella in it is Auriga, the charioteer. Its brightest star, like I said, is named Capella, and it represents a small goat. And that star is located about 42 light years away from our solar system. A light year is the distance that light travels in a year. So as you go outside and you look at Capella up in the constellation Auriga tonight, you're not seeing that star as it is, but rather as it was 42 years ago, because that's how long it's taken for the light from that star to get to us. Now, I find Auriga interesting because, in terms of trying to give ourselves orientation on the sky on a larger scale, that area of the sky is what we often refer to as the Galactic Anti-Center, which means that here we are in the Milky Way galaxy, our sun being one of hundreds of billions of stars in the Milky Way galaxy. And we are not at the center of our galaxy, we are not at the edge, but we're somewhere about halfway out. And so when we look up towards the constellation Auriga in the sky, we're not looking towards into the center of the Milky Way. We're actually looking opposite, out away from the center of our own Milky Way. And then near Auriga is an extremely faint constellation named Lynx. And this is a constellation that was developed in the 17th century to connect the dots between brighter stars, because astronomers use constellations not just to tell stories, but we use them to give positions on the sky. If I wanted to give you really precise data about where to look for an object on the sky, I would use something called right ascension and declination, which is the sky analog to latitude and longitude. But I can give you a feel for where we're talking about in the sky if I were to say I'm talking about the brightest star in Lynx. And so constellations filling the entire sky, not just connecting only the brightest stars, have been important in the history of astronomy for us to communicate. But this is an extremely faint grouping of stars. In fact, it was named Lynx because it's thought you would need the eyes of a lynx to see it, because lynx have good eyesight. I guess there's always been that myth about them. The most famous, probably, constellation up in the sky tonight, though, is Orion the Hunter, setting over in the western part of the sky after the show tonight. It Most people find Orion by looking for its three belt stars, which are noticeable because they look like a set of triplets up in the sky. but they don't have anything to do with each other really. In fact, the middle star is about twice as far away from our solar system as the other two. And so I like to point that out because it reminds us that we don't have good depth perception on the sky. And the reason for that is that stars all have different temperatures and different sizes. And that combination means that they have different total brightnesses. And so stars can be really close to our solar system, but be so faint we can't see them with the naked eye, or stars can be far away and we can still see them. And stars can be different distances from us and yet look the same brightness, which is what we're seeing with the belt stars of Orion. The bright star at the right foot of Orion is Rigel, and that's located over 700 light years from our solar system. And then the bright star up the left shoulder is Betelgeuse, located about 400 or so light years from our solar system. And that's the one we're still hoping will blow up in a supernova. It hasn't done it yet, but we keep hoping. And Orion is accompanied on his hunt across the sky by his hunting dogs, Canis Miner, the small dog. The brightest star in Canis Minor, which is located right next to the S, is Procyon. And it's bright in our sky because it's located only about 11 light years from our solar system. So it's a relatively close star to our solar system, as is the brightest star in Canis Major, the big dog. The star Sirius. It is the brightest star we see in the nighttime sky from the Earth. And it's a combination of two reasons for that. It is relatively close to us at only about 9 light years away. It's not the closest star to our solar system, but it's pretty close. And it's also a hotter star than our own sun. So it puts out more light to begin with. And so that combination led it to get the word Sirius as its name, where Sirius comes from a term that means glowing or scorcher. And so it's been known to be the brightest star in the sky for a long time. And you may also have heard of this referred to as the dog star because it is the brightest star in the big dog, Canis Major. And then over here in the same part of the sky, there's a unicorn, Monoceros, which is also one of those constellations that was developed in the 17th century to fill the dots in between some of the brighter constellations. Whereas it's not easy to see with the naked eye, it has some beautiful, what we call deep sky objects, objects that you can only see with the benefit of a telescope, including the beautiful Rosette Nebula, which is named so because it looks like a rose. And then there is a very large constellation lurking in the southern part of the sky, and that is Hydra, the sea serpent. It is the largest of the 88 modern constellations that astronomers use. And the brightest star in Hydra's name is Alphard, which comes from an Arabic term that means the solitary one. And if you notice there, that brightest star that you can see there in Hydra, it is in a gap of where there are very few bright stars. And so you can see why they would call it a star that is alone. And it's located about 170 light years from our solar system. So if you go outside tonight and you look for Alphard in the sky, once again, you're not seeing it as it is, but rather as it was 170 years ago. There's more dogs in the sky. We have Canis venatici here. Its name comes from a Latin term that means hunting dogs. And it is often depicted as being the hunting dogs associated with another constellation up here on this part of the sky, Bootes, which I'll show you. This is actually an ancient constellation. They were included by the Greek astronomer Ptolemy, who first made what we consider a catalog of constellations in the 2nd century. And these stars, though, were not originally their own constellation. They were part of others, and then over the years have been misidentified, and then eventually, basically, they floated around as different parts of constellations. And then in the late 1600s, during that catalog of new faint constellations, they were basically given their own constellation. And so, when we talk about constellations changing over time, they don't do so astronomically like the stars changed, but our constellation boundaries have changed. Where we've drawn the constellations have changed. Here's another constellation you may not have heard of that's up in the sky tonight named Coma Berenices. And it means Berenice's hair. And this comes out of a story in Egyptian mythology where there was a queen who, actually, no, Greek mythology, but it refers to an Egyptian queen. She begged the goddess Aphrodite to bring her king, her husband, safely home from war. And she said, if you do, I will cut my hair, which I'm extremely proud of. I will cut my hair as an offering. And when the king returned home safely, the queen did as she promised, and she cut her hair and made an offering at Aphrodite's temple. And the offering pleased the goddess so much that she put it up into the sky so that the hair, Berenice's hair, could be there forever. And so that's the origin of this constellation named after somebody's hair. But once again, Coma Berenices, it sounds a little bit more poetic than Berenice's hair, but that's what it means. And then we have the constellation Bootes, the herdsman, and this is the constellation that the hunting dogs sometimes are associated with. Its brightest star down at the base of what's often referred to as a kite, but I call it an ice cream cone. Its brightest star, Arcturus. That name comes from a phrase that means guardian of the bear, likely due to its proximity to Ursa Major in the sky. And Arcturus is one of the brighter stars that you're going to see here in the spring sky and the early summer sky in the evening, located about 37 light years from our solar system. And then what we can do, we can follow the arc of the handle of the Big Dipper. We follow that arc to Arcturus. And if we continue making that circle, we say we speed on to Spica, which is the brightest star in the constellation Virgo, the Maiden, which is the second largest of the constellations that astronomers use. The bright star Spica there, its name refers to an ear or a sheaf of wheat. And when you take a look at the mythological representation, the maiden is usually holding a sheaf of wheat in her hand. And Spica is the 15th brightest star that we see in the evening sky, located about 260 light years from our solar system. So once again, we're seeing stars of different distances being similar brightnesses in the sky. Now, Virgo you may recognize because it is a sign of the zodiac. And so let's fill in the rest of the signs of the zodiac that are up in the sky tonight. And so you have likely heard these names: Leo, Cancer, Gemini, Taurus. The reason why these constellations gained cultural significance is because the ecliptic follows or passes through them. I have put the ecliptic up there as a green line. You might notice the green line has months of the year next to it. And that's because the ecliptic actually is the path of the sun on our sky, or the apparent path of the sun on our sky. So we can see where the sun is located on any given day of the year. And because we are here at the beginning of April, and I have this set for 8:30 tonight, you can see that the beginning of April is below the western horizon. So we have it set correctly for where the sun should be tonight. And so, because the sun was noticeable in that it moves amongst the stars, these constellations showed changes. And by that, the moon and the planets also travel through these constellations. And it gives us an idea that our solar system is flat like a pancake for the most part, and that the large objects all orbit on the same plane around the sun. So we're seeing the apparent path of the sun as it moves through the sky as seen from the Earth. So let's continue our journey across the sky by looking at the rest of the zodiac signs. We have Leo, the lion, with its bright star Regulus at the bottom of the backwards looking question mark at the front of the lion. This is a fairly bright constellation. So even from a large city like San Diego, you can typically go outside and, if you have a clear sky, identify the bright stars of Leo. That the star Regulus is about 70 or so light years from our solar system. And then the bright star at the tail of the lion, named the Nebula, it has a similar brightness up on the sky, but it's about half as far away. And so once again, you're seeing that we don't have very good depth perception on the sky. And so we go from a bright constellation like Leo to an extremely faint one, Cancer, the crab. It is the faintest of all the zodiac constellations. And from a city like San Diego, it's really hard to see the individual stars. So if you and I were outside tonight together and I wanted to show you where Cancer was up on the sky, I would say, hey, look at the backwards question mark at the front of the lion. Yeah, look a little bit west of that. That's how we would find this constellation up on the sky. And if you're wondering where in the mythology this crab comes from, in Greek mythology, this is the crab that appeared while Heracles was fighting the Hydra, and the crab bit Heracles. And so Heracles killed the crab. But the goddess Hera, who didn't like Heracles, said, I'm going to put this crab up in the sky just to annoy you. And that's basically why this crab is up in the sky amongst the stars, taunting Heracles forever. The next sign of the zodiac, going to the west on the sky, is Gemini, the twins, Castor and Pollux. And if you go outside and look for them tonight, they really do look like twins. And they've looked like twins for a long time, although they're named Castor and Pollux after twins from Roman mythology. Back as long ago as recorded Babylonian astronomy, this area of the sky was known as the Great Twins. And so this shows us that not only do constellations keep their shapes for long periods of times, but that typical stars even keep their same brightnesses, at least visible to the naked eye, for very long periods of time as well. Now, although they look like twins up on the sky, they have nothing to do with each other. In fact, one of them is about twice as far away from us as the other. And then the last sign of the zodiac that I wanted to mention to you tonight is Taurus the Bull, which is a very large constellation full of a lot of interesting objects, including the Crab Nebula and the Pleiades. The brightest star, the red eye of the bull, is named Aldebaran. It's located about 65 light years from our solar system. And the V that you see next, the V of stars you see next to the letter T there that marks the face of the bull, that's actually a cluster of stars called the Hyades. They are all associated with each other, except for Aldebaran. That's just there due to line of sight and is just not actually part of the rest of the V, strange enough. But there is another bright object in the constellation Taurus tonight that I wanted to point out to you, and that is Mars. So the planet Mars is up in Taurus tonight, and it is the one planet that is easy to see with the naked eye that's up in the nighttime sky this evening. So there's been a lot about Mars in the news, and so I want to take this as an opportunity to talk about Mars a bit. So this is an image from the NASA InSight lander, and what you're seeing there, that dome thing, is actually a seismometer, and it is looking for Mars quakes. And it has recorded recently two strong, clear quakes from the same seismic region. It's actually received information from before, seismic information from before. And these were on our Richter scale, like a magnitude 3, about 3.3, 3.1. And it's interesting because a lot of these quakes are located in a single region on Mars called Kerberos Face. And so what is keeping Mars seismically active, particularly in that region, is something still that we have to figure out. But so far, this lander has recorded over 500 Mars quakes. And what I find really interesting about this one, and I hope to see them sort of disaggregate the data at some point, is that the seismometer is sensitive enough that some of these Mars quakes are likely impacts that we're just picking up the seismic waves from. So I want to know more about that. So the NASA InSight lander is actually on Mars to learn more about the interior of Mars. Why is it seismically active and so on. But I wanted to show you this image from Mars Curiosity. Mars Curiosity has been looking up at the sky and with one of its navigation cameras, and it's been picking up the most lovely high cirrus clouds in the sky. And so there have been lots of images of Mars clouds recently. This Curiosity is in a part of Mars called Gale Crater, and it's a region where clouds tend to form more, I think, almost on a seasonal pattern, if I recall correctly. And so this is the time of the Martian year that they're more likely to see these clouds. But anyway, clouds up in the Martian sky, I love showing them. It's one of the ways that Mars seems so familiar when we take a look at images of it. And then I wanted to show you this one because I want to make sure you know that's not a rainbow. Okay. I've seen some people refer to it as a rainbow. It looks like a rainbow. This is an image from NASA's most recent spacecraft on Mars, which is the Perseverance rover. And rainbows actually would be really, really, really hard to make on Mars because rainbows, as in our atmosphere, form from large water droplets. And it's how the light gets refracted and reflected off of these round water droplets in the sky. But although Mars does have some water vapor in the atmosphere, it's not enough to condense and make these sort of large droplets that would make a rainbow. So this is actually due to the optics of the camera. This is a lens effect. And so that's not actually a rainbow, but I had to show it to you anyway because it's one of those things that I saw getting passed around as, oh, look, a rainbow on Mars. Sorry, it's not. And then speaking of perseverance, all right, so this is one thing that I'm really excited about. So the cameras, especially that are on these, they have the ability to move around a bit. So just like Curiosity, which Perseverance looks almost okay. Curiosity behind me, right? Perseverance is almost a twin. And so they can take selfies, but I want to direct your attention to this little thing over here in between the tire tracks. That little thing is called Ingenuity, and it's a helicopter. And so what's going to happen next week is when they're planning on doing this. So this little helicopter was stowed kind of in the belly of Perseverance, and they lowered it to the ground. And then Perseverance drove away, which is why you're seeing it in the middle of the tire tracks. And it has lasted its first couple of cold Martian nights. And so it's doing fine so far. And then the idea is it's going to attempt to fly. And it's not this is a proof of concept design, so there's no actual science experiments that are really tied into it other than can it fly. And one of the reasons why that is important is that Mars has a really, really, really thin atmosphere. It's less than 1% of our own atmospheric pressure. So when we get into airplanes or helicopters here, the air helps keep us up. That's what we call lift. There's not really much in the way of lift on Mars. So, but Ingenuity is going to try to fly. I think they're aiming for April 11th or April 12th was the last I saw. So keep an eye on the news, and I'll update you next month at the Sky Tonight if to see how this flight went. But I also just love how you can see that this rover has left something behind on the ground. And it's an example of what some people might call space junk, the way we litter stuff all over the solar system. And so the goal for tonight is to talk about um, human made space junk. But it's not junk, we use it for a reason. Um, every month, this graphic is being generated of all of the active spacecraft in the solar system and where they are and upcoming events. And so you can see that we have a lot of spacecraft out in the solar system, including a lot on Mars. And I'm going to make that even look more bizarre later. And so, but when we send these spacecraft out into the universe, they, for the most part, just stay out there. And so we are just kind of throwing stuff out there and leaving it in the sky, but or in space. And some of these have been out there a long time. So this is what the Voyager spacecraft looks like. And Voyagers 1 and Voyager 2 were launched in the 70s and they're still going. They're leaving the solar system. And they will keep going until they run into something. But for both of them, and as well as the Pioneer spacecraft, there are no stars or systems along their path that they'll reach within millions of years because of the speed with which they're going. And so some of these objects that we've sent out into our solar system are actually leaving our solar system and will be around for maybe somebody else to find somewhere out there traveling into their solar system. Another spacecraft that is way far away from the Earth now is the New Horizon spacecraft. And I pulled this data from their website this morning, where you can see where it would be today. You might remember this is the spacecraft that flew by Pluto in July of 2015 and flew by Arrokoth, a Kuiper Belt object, in January of 2019, and it keeps going. And so this is something that, in terms of exploration, is incredibly important, incredibly useful, but it's still going to be out there forever at this point. I wanted to mention a couple of other active solar system missions before I get to what we really need to be concerned about as space junk. I'm only affectionately referring to some of these as space junk. This is Juno, which is currently in orbit around Jupiter. And it was launched in 2011 and entered orbit around Jupiter in 2016, and has been sending back really interesting data ever since, including lots of lovely images with a camera made by Malin Space Science Systems here in San Diego County. But it's been giving us lots of great data on Jupiter's gravitational field and magnetic field, which is what we really sent the spacecraft out there for. And it'll stay out there in orbit around Jupiter until perhaps we intentionally will deorbit it into Jupiter. And deorbiting is the fancy way of saying we're going to crash it into Jupiter. And we do that so it won't land on any of Jupiter's moons and possibly contaminate those moons. And then out in the asteroid belt, I wanted to mention Osiris-Rex, the spacecraft that we're seeing here as it sampled the asteroid Bennu back in October. Just today, the Osiris-Rex spacecraft completed its last flyover of the asteroid. And I believe in May, if I recall correctly, the spacecraft should fire its thrusters. So in this case, the spacecraft will be heading back towards the Earth. And then in September of 2023, the sample collector, right? So it basically went down, tagged the surface, kicked up debris, and then collected a lot of this debris. The collector is actually going to be thrown back at the Earth, ejected back at the Earth by the spacecraft. But then the spacecraft itself is going to keep going. And if I recall correctly, this collector should land somewhere in Utah. In a flat sort of deserty region so that we can retrieve the sample collector. As we continue looking at various spacecraft throughout the solar system and where we leave them, I went to the Planetary Society website because they update the Mars Exploration Family Portrait, as they call it. And this has all of the current spacecraft at Mars and the historical ones as well. And you can see we've gone to Mars a lot. We have gone to Mars a lot because it is so familiar. Most of the spacecraft here have made it. A lot of the ones from the former Soviet Union did not. But currently at Mars, there are spacecraft from NASA, from the European Space Agency, let me see if I can go through all of them. The United Arab Emirates got one there recently. India has one there. And so this is internationally a large effort in studying Mars, because out of all the planets in the solar system, it is the most Earth-like, and in terms of us exploring, would be the one that we would go to. So, but those things that have landed on Mars, we land them there and then they stay there. And so we are just leaving behind spacecraft on the surface of Mars. And sometimes we can see it really obviously. So when the Mars Curiosity spacecraft landed, and that's what's labeled as MSL on there because of Mars Science Laboratory, there was a parachute involved and a sky crane involved. And you can actually see in this image from the Mars Reconnaissance Orbiter where all those different pieces landed on the surface of Mars. And we have seen this similarly recently for the Perseverance rover as well. And then as Curiosity has been roving along, parts of its tires have been breaking off. And so this material is also being left behind on Mars. And then I have to mention this one. I forgot about this image till I came across it today. It's one of my favorite images. benign plastic. This is a little bit of plastic that came off of the Curiosity rover that you can actually see in one of the high resolution images of the ground. And I just love how it's called benign plastic. Yeah, we just littered Mars with some plastic, but it's okay. It's all good. What they mean by benign here is nothing important fell off the rover. So I forgot that that is actually the official labeling from NASA was benign plastic. But as you can see, Curiosity and Perseverance are roving around Mars right now and studying it and leaving little bits of themselves behind. And then this is a location map of all of the lunar landings, including uh, ones that had crews, and so all of the purple Apollo ones had people in them. The other sort of light blue ones, the Surveyor ones, were other NASA spacecraft that were just robotic spacecraft. The Luna spacecraft were from the Soviet Union, and then the Chang'e ones are from the Chinese Space Agency, and they are currently active on the moon. And so you can see there's been a lot of spacecraft that have landed on the moon as well. And we can see little bits of them that are left behind. So these are lunar reconnaissance orbiter images of here. This is the Apollo 11 landing site, and we can still see the lunar module and some of the discarded bits on there in Mare Tranquillitatis. And then here are images of the Apollo 14 and the Apollo 17 landing sites, where we can actually still see the descent stage and ALSEP, which is the scientific instrument packages and stuff. So we actually can see the stuff that we've left behind on the moon. And in fact, the ALSEP, the scientific packages there, we still bounce lasers off of mirrors that were left in those packages to help us actually get the distance to the moon so that we can see how the distance from the Earth to the moon is changing, because it is. The moon is moving away from us at about the same rate at which your hair grows, if you want to think about that. And so now that brings us back to the Earth. So we have been putting satellites up in orbit for a while. This is Telstar, the first communications satellite that was launched about 60 years ago. Gives you a sense of size of some of what the earlier telecommunication satellites looked like. But we've had a lot of stuff in orbit, and this is the stuff, I'm kind of teasing about littering the solar system, but some of this stuff is what we consider to be space junk and stuff that we really need to be concerned about. This is the Hubble Space Telescope and the Earth, and you can see astronaut Story Musgrave on the robotic arm of the old space shuttle as it was doing repairs to the Hubble Space Telescope early on. But when the space shuttle was in orbit, when it would come back, we would actually see little dings to the windows. And this is a pit in the window of one of the shuttles where you can see it got hit by something while it was in orbit. And so the question is, what are these little bits and pieces of things that are in orbit? And sometimes it's stuff that we've left behind because we've done a lot of large scale building now in orbit. So this is the International Space Station. It was an image taken by the space shuttle Atlantis, and it's a football field in size. Like it's really really huge. Now only a small part of that is habitable by humans. A lot of what you're seeing here are the solar panels and so on. But we have this huge actual object up in what we call low Earth orbit, and it also gets hit. You see on the right an astronaut in the cupola of the International Space Station, and on the left, you actually see a little impact in that window from a collision. And this glass can withstand impacts by objects to about a centimeter or so in size. And for something larger, we actually change the orbit. We move slightly the orbit of the space station. And typically, about once a year, the space station has to move slightly to avoid getting hit by something out in space because there's a lot of stuff in there. So, what this is a model of what we call low Earth orbit, which is really, really, really close to the Earth, and it's labeled in blue. That big green broad band there is what we call mid-Earth orbit, and then we have high Earth orbit in the red, way far away. About in the middle here, that's where a lot of GPS satellites are. And then out here is geosynchronous orbit. But a lot of your telecommunication satellites, your Hubble Space Telescope, your International Space Station, they're all way down here near the Earth, just a couple hundred miles or so above the ground. And so I want to give you some numbers to let you know how much stuff is up in orbit. I went to the Center of Concerned Scientists. I forget the actual acronym right now off the top of my head, but they actually, or excuse me, that's the Union of Concerned Scientists. And they have a page where they keep track of the number of satellites that are in orbit. And in the total number of operating satellites in orbit right now are 3,372 when I took a look at the data today. Um, to give you an idea, though, I last did a similar talk like this about 5 years ago. And at that point, there was only about 1,500 satellites in orbit. So we have over doubled in 5 years the number of satellites that are up in orbit, with the United States being the largest contributor to that, and commercial satellites being the largest contributor to that. So I went to a database today to generate how many satellites are actually in orbit, and these are not just the operational ones. This is everything that's up there wandering around right now. The satellites that are no longer working but are still in orbit, and this site is tracking over 19,000 satellites. And so you're seeing a couple of different things now. The sort of rings at a large distance from the Earth. That's geosynchronous orbit. What geosynchronous means is that the Earth rotates once every 24 hours, and these satellites turn in sync with the Earth, geosynchronous orbit. So that is the orbit where they go around the Earth, and it takes them 24 hours to do it. So they're always above the same location on the Earth. Low Earth orbit is full of so many white dots now, it's hard to see the Earth itself. All right, in this perspective. So those are like I said, that's where our telescopes are, our weather satellite, lots of our weather satellites and our communication satellites and so on. And I said there's only about like a little over 3,000 of these that are actually operating, right? So the rest of this is what we would actually call space junk. It's out there in space around the Earth, and it's no longer functional. And so we have a couple different possibilities for what will happen to these objects. Like I said, and this is the same image just from a different angle so that you can get the different perspective. And so you might be wondering what all is being tracked out there. Well, we have non-functional spacecraft as well as functional ones. We have the boosters, the rockets that help get some of our spacecraft to even higher orbits, but that don't fall all the way back down to the Earth. Some of those lower stages of spacecraft are there. There are debris from weapons testing. There used to be space weapons testing. There is lost equipment up there, like pliers and a glove, or things like that that have drifted away from astronauts during spacewalks. There are tracking more. These are all of the pieces that we know about that are larger than about 10 centimeters or so and greater in size. But we estimate that there's probably up to about 500,000 particles that are out there that are between 1 and 10 centimeters in size that we aren't tracking because we don't really know where they are. So there's a lot of stuff out there. And so, what do we do with this stuff? Well, some of this stuff just its orbit decays and it falls back down and it burns up in the Earth's atmosphere, or it doesn't and it makes it to the ground, or some of it, the smaller stuff, does burn up. If we have fuel, we can boost these to what we call graveyard orbits, which are even further out so that they won't fall down to the Earth, but that they're no longer in low Earth orbit. But there's so many things there. You might be wondering, have there ever been any collisions? And the answer is yes. And so in February of 2009, the first known collision between two full satellites occurred. It was between a Russian communications satellite and, if I recall correctly, a Chinese satellite. I can't, or no, it was an Iridium satellite. So This Cosmos satellite, it was no longer working. It was not functional anymore. And their paths crossed and they ran into each other. And when that happens, you put a bunch of those little small particles up in there. So instead of having two distinct satellites now in orbit, you have a bunch of objects now in orbit that we have to keep track of. And this is important for reasons I'm going to talk about in a bit. And this brings us now up to things called satellite constellations. All right, the pretty name. Astronomers hate them. So, satellite constellations right now are being sent up by Amazon is planning to put up a satellite constellation. There's a group called OneWeb, and perhaps the most famous one is the Starlink program from SpaceX, where they're putting up satellites that are supposed to help give broadband internet on a large scale. But they are launching literally thousands of satellites up into orbit. And so this is an image from a telescope at Cerro Tololo in Chile. And all of those streaks here you see are Starlink spacecraft passing through um, a set of observations from an astronomical observatory. Here's another set of, this is another case where a professional astronomy observatory taking a set of images, and all of those trails are from Starlink. The Starlink satellites are actually bright enough. I've seen them from San Diego. You can see them just going as a streak across the sky. A couple of weeks ago, you may have heard people up in Seattle saw something burning up in the atmosphere, and that was a failed Starlink satellite. And so we are sending these corporations are sending up thousands of satellites now. And that actually is the biggest difference between, when I said 5 years ago, we only had about 1,500 and now there's over 3,300 satellites up in the sky. A large part of it is due to these satellite constellations, or what are often called mega constellations. SpaceX has already launched over 1,000 of these satellites up into the sky. And one of the things that we are determining is that the reflectivity from these is actually making the sky brighter. And that as we continue to add the spacecraft up in the sky, it may add up to 10, may actually increase the brightness of the sky by up to 10%. But there's an even more concerning issue. This is a diagram from the European Space Agency tracking particles greater than about 1 millimeter in size. So this is what the Earth would look like. What does having thousands of satellites in orbit, perhaps breaking up, going defunct, not working anymore, and leaving them there? What does this mean? Well, a NASA engineer named Don Kessler actually observed that at some point, you get so many spacecraft up there, you get so much orbital debris that you might not be able to launch anything safely through it anymore. And then there's also the possibility for a collision to trigger a cascade of collisions. So, for example, if you saw the movie Gravity, you might remember in the movie Gravity, there was a collision that kept, I got so emotional during that movie because it showed the Hubble Space Telescope breaking apart, and that just wounded my soul on a deep level. But that sort of cascade of collisions, that's actually what we're worried about for all practical reasons, that the collision of objects could cause a cascade effect. And once that happens, once you have so much stuff in orbit, we can't send stuff to Mars anymore. And so having all of these satellites in orbit without a plan to clean up the space around us could actually mean that this era of space exploration could come to an end because we didn't figure out how to clean up after ourselves. And so whereas I might be affectionately referring to, but curiosity behind me is space junk because we're littering Mars. This is actually the stuff that we really have genuine concerns about in terms of space exploration, and just even from an astronomical point of view, being able to observe the sky without satellite tracks going through all of our images. So how do we clean up after ourselves? Well, there's some planning. NASA, when it sends up a spacecraft, has a plan. Either it's going away from the Earth and it doesn't need to be brought back down, or we usually do intentional crashing into the oceans. We actually deorbit these spacecraft with intention. Um, but corporations tend not to have to play by those rules. And so we would hope that in the future, that if you're going to be sending up spacecraft, that you better be taking down the ones that you put up there that don't work anymore. So basically clean up after ourselves. This graphic here is from the European Space Agency's Clean Space Initiative, where in 2025 they're going to try to start doing active removal of defunct satellites in space. So this is an artist representation of what that might look like. And that's the sort of thing that we are thinking about, that we will have to think about, so that we can safely continue to look out back at the Earth from space and to continue exploring the space around us. We need to clean up the junk in our low Earth orbit. And so that's talk about space junk, what it is, where it's located. And I will happily take any questions you might have.
There are indeed questions.
And would you like me to stop sharing?
Yeah, I think that
Okay.
would be good.
All right.
This way we
There
can
we
see
go.
you better. It's always nice to see you, you know? Man, the information you always give us, it's just amazing. I just blows me
Okay.
away every month. All right, the first question is, what is the biggest space junk ever found, or that we put up there and we know is out there?
So one of the ones that we know is up, I mean, the largest thing that we have put up into space is the space station.
Mhm.
It's so large that we couldn't launch it up all at once. It was built in chunks by continued launches of the space shuttle and the Russian Soyuz spacecraft and Prognos spacecraft, going back and forth between the Earth and the space station as it was constructed. And so that is the single largest artifact, space artifact, that we have created as so far.
Nice. That is big, yeah.
It is. It's huge. Yeah, it's hard to believe, but yeah, it's absolutely huge.
Yeah. And we have a question about the space station. Is it visible in the night sky? And if so, how can we find out about the details of its visibility?
Yes, I'm completely blanking. There's even a Twitter feed, but there are sites that you can actually go look and it will tell you when and where the space station is visible. So you look for space station flyovers, and and sometimes it is bright. It's very quick,
Yes.
because at low Earth orbit, the space station orbits the Earth about once every, just say like an hour and a half. That's a good number to keep in your half. It's not perfect, but maybe once about every hour and a half. So from our point of view here in San Diego, you're going to see it as a bright flash going across the sky. And the reason why we can see it is because it is so big. When it's at the right angle with the sun, it reflects sunlight. And so that's what we're seeing.
All right, I actually found the link, so I'm gonna put that in the chat
Oh,
real quick for
thank you.
everybody. They named it, if I can open my chat, where's my chat? There we go. Give me just 1 second. So here's the link. The link is
Oh,
nice.
spot the station. Thank you.
Spot the station.
I knew it was something catchy enough that I should remember, and I just did
Okay,
not right now.
all good. But I like that they named it that way. It's really good.
Yeah.
And then we have a question, will NASA support removal of space junk for polluting corporations?
I don't know how to politely phrase this. Let me think about this for a second. Let's see.
Oh,
The try to say this. Um, what I would like is if to launch stuff into space, you did have to, corporations would have to sign some sort of agreement saying that they will start to mitigate um, the the problem that they are exacerbating. NASA is, NASA does what it can. As you see, the European Space Agency is even starting their own program to try to go up and clean stuff up. But I don't know, NASA's been trying to support commercial space flight. It would be nice if the commercial space flight cleaned up after itself.
hey, I agree. Yeah,
Yeah, I'll leave it there.
exactly. Another question is, what's the largest piece of abandoned and unused space junk?
So I'm trying to think of that because it sort of depends on where you're looking at it, right? So the large satellites like the Hubble Space Telescope, for example, they're about the size of a bus, but we tend to bring those back down. So, for example, when the Compton Gamma Ray Observatory, when we knew that it was coming to the end of its life, it got deorbited, it got crashed into the Pacific Ocean. But that's sort of like satellites can actually be really big. Satellites can be the size of a coffee table to the size of a bus. And so there is a big range in sizes. And so, especially if you start to take into account the solar panels usually will come off, they will burn up as you go into the atmosphere. But some of the larger bits, like, you know, at some point we will deorbit the Hubble Space Telescope, and that will be a very, very, very sad day. But you would not want that falling on your house because a big chunk of it would actually make it to the ground. And so, now in terms of other places in the solar system, um, Spirit and Opportunity on Mars, they aren't the size of an SUV, but they're not like Opportunity is. They're a little bit smaller than that, but all over the surface of Mars now, and as you can see on the surface of the moon, we've got these little objects that we have left behind as artifacts of human exploration.
Yeah, it is. I mean, you said that Mars, they're going to shoot back the probe collector thingy. How do people even calculate that we get that back without it hitting some of these
No,
things?
that's a really good question, right? So, with the case of the Osiris-Rex spacecraft bringing back asteroid samples, and we've actually done this before. There was a sample return mission to a comet, the Stardust mission that we sent back an aerogel pack, and you can actually aim. You have to get it at the right speed and at the right angle so that it will survive coming through the Earth's atmosphere. But because we understand so well where the Earth is going to be on a specific day, what side is going to be facing, um, you know, we can get these things down to the minute. We understand orbital mechanics that well. I always tease my physics students, we've understood the physics for hundreds of years. The engineers just had to catch up, right? In terms of making the craft themselves. But Newton's laws and Kepler's laws of planetary motion, we can figure out where these things need to be at what time. And so what usually happens for when we're deorbiting something into the Pacific is that they'll actually send out military ships to do a clear space, to clear things out like that.
Yeah, which is good.
Yeah.
I think that's a great idea. Um, you mentioned that there was a NASA scientist who calculated at one point we won't be able to safely send stuff out anymore if we keep on doing it. What is the time frame for that? What are we looking at?
When SpaceX started sending up the Starlink spacecraft, that wasn't really on the radar of astronomers, because they market it as a communications satellite. I think it just had to go through FCC clearance. And so it just had to follow the rules of the FCC in terms of what wavelengths, or excuse me, what frequencies it's broadcasting or receiving at. And so this sort of, are you sending us over the top? Are you tipping off the Kessler system, was actually just not part of the calculations, which is one of the reasons why astronomers are so concerned about Amazon and other companies saying we're going to send this up too, because the goal is to provide broadband satellite internet all over the world. And it's not like it's a bad goal, but the potential issues that come out of it are huge. Several of the Starlink's satellites have failed and aren't functioning, and their orbits didn't reach exactly where they were supposed to.
Yeah.
And that's the sort of thing that causes collisions down the road.
And you also mentioned that they're bright, right? They reflect quite a bit, and you said it's going to increase by 10%. What does that do for astronomy research?
For astronomy research, the biggest problem is that those streaks of light going across the you know, there are particularly some cases like the Vera Rubin Observatory has been set up to be like a large sky survey. And so the idea is that you're looking at large parts of the sky for long lengths of time. And they've been doing studies showing how these satellite streaks are going to impact their exposures. SpaceX has sent up some that they have put on, when they heard astronomers going, well, what are you doing? They said, okay, we'll paint some of these satellites black so they'll reflect less light, but if you paint them black, they also heat up more, which causes problems with the satellites themselves. And they're still reflective because you can paint a shiny object black and sometimes it's just shiny and black. So you still get like reflectiveness. So this has a huge impact on astronomical research, but you can see these with the naked eye. And I actually find it kind of offensive that these satellites can alter the sky for humanity, and they only had to get permission from the FCC, but it's changing the sky for everyone. And so just it is culturally can have an impact on a larger scale, even than just talking about astronomical research, which is an annoying. And then again, worried about long-term potential issues with the Kessler syndrome. And then we would have to try to safely clean up the sky before we could launch another Perseverance to Mars.
Yeah. And that's it leads up nicely to a question we just got. Do new satellites have to be approved before put into orbit? So we know some of them by the FCC, but what about NASA or any other governmental approval?
There are governmental entities have signed something called the Outer Space Treaty. There are kind of rules that the space agencies, the national space agencies, play by that corporations are not signatories of.
Thank you for that. All right, and that puts us a little bit past 6 p.m. and I have one more question I will answer. Hi, Mary. It comes
Hi,
from Mary, and we know Mary. Mary was one of the first employees at the Fleet Science Center and also did our planetarium show. So hi, Mary, good to see you. And she was asking about the sky tonight, when it might be still in person or in person again. And we don't know yet, Mary. It will happen, hopefully sometime soon, but we're not sure yet whether it's going to be May or June or maybe even after that in July. We just have to see where generally the instructions go, how we feel it's safe, what science says, right? We're going with the science, we trust the science. So we're going to go with that. But since the fleet does open on Friday for weekends, so Fridays through Mondays, we hope that eventually we can expand that to a full week of opening and then bring Sky Tonight back in person. And Lisa kindly has offered, at least in a transition period, to see if we can make it work both in person and virtually. So if there are some people who don't quite feel comfortable yet coming back when we decide to do this live again, she said she would be open to doing both the live and the virtual. So I really appreciate that. And of course, we'll keep you up to date on where we are with that. So keep an eye on our website, make sure you sign up for our newsletters. This way you won't miss any of the great announcements. And of course, there's social media. We have a great social media manager. She puts everything on Facebook and Instagram and Twitter. So just follow us on your favorite channels or your favorite way to stay in touch. Thank you so much, everybody, for joining us tonight. We hope you enjoyed it, and we hope you will join us again next month, wherever it might be, in whatever space it might be. And next month, we're going to look at the colors in space. Is that right, Lisa?
Yes,
Yeah.
Colors of Space.
Perfect. So don't miss out on that. Check out the website. We have many more events that should be fun, and I do hope you're excited about the fleet opening and maybe coming to visit us this weekend. And with that, Lisa, thank you so very much. And everybody have a wonderful night and stay safe and healthy.
Thank you.
Thanks.